Okay, so here we have the diagram again of the Smith's lot. It's a 100 by 240 foot lot with a 40 by 80 foot house situated on it, a 10 by 20 patio, 10 by 40 driveway, and a 40 foot in diameter pool. So our instructions are to figure out how much it's going to cost to cut their lawn. If we're going to assume that all the other space in the lot is nothing but grassy area. Okay, so the first thing we need to do is actually calculate the area that the grass takes up, and then we can use the figure provided of 0.03 cents per square yard to figure out how much it's actually going to cost. But the first part is just area. Now when I look at this problem, I see a massively large rectangle, which is their lot, and then 3 smaller rectangles and a circle. So if I'm trying to find the area of the region inside the large rectangle but outside of these regions, I'm going to find the area of those 4 separate regions, the pool, the patio, the house, and the driveway, and subtract those from the area of the total lot as if there was no region sitting on top of it. So basically, if I want the area of the grass can be found by taking the area of the lot and subtracting the area of the pool, the area of the house, the area of the patio, and the area of the driveway. Now 4 of those regions, as I've already said, are rectangles, and the other one is a circle. And we know formulas for the areas of each one of those. So the lot is just a 100 by 240 foot rectangle, so 100 times 240, it's length times width, minus the area of the pool. The pool is a circle, and the formula for the area of a circle is pi times the radius squared. Well, we know the diameter is 40 feet, so the radius is 20 feet, so the area of the pool is going to be given by pi times 20 squared, minus the area of the house, which is a rectangle, 40 by 80, minus the area of the patio, also rectangle, 10 by 20, and minus the area of the driveway, a rectangle that's 10 by 40. So we're just typing things into the calculator at this point and getting figures. This is 24,000 minus 20 squared is 400 times pi, minus 3,200 minus 200 minus 400. Notice I left this as 400 pi instead of finding the decimal value. I'm going to try to avoid figuring out what the decimal is until as late as possible. So I'm going to do 24,000 minus 3,200 minus 200 minus 400, 16,200. I've still got my minus 400 pi. And so what I do at this point then is type this expression in your calculator just as it is, 16,200 minus 400 times pi. And actually use the pi button in your calculator. Don't use any rounded values for pi that you may have learned along the way. Your calculator has a pi button, so let's use it. So if we type that in and subtract, we get 14,943, I'm going to round to 2 decimal places, 0.36 square feet. And that would be the area in square feet of the grassy area on their lot. Okay, what we're supposed to do is actually find the cost, though, to cut this lawn. And the cost is based on the area, so we've now found the area, and we know that the ABC Lawn Service charges 3 cents per square yard of lawn. Okay, so right away we have a problem. We know the square footage of the lawn, but we don't know the square yardage. So I need to change square feet to square yards, which boils down to the question of how many square feet are there in a square yard. Well, a square yard would be, a square that was exactly 1 yard by 1 yard on all sides. Now, if 1 yard is made up of 3 feet, we can look at 1, 2, 3 feet on each side. And so how many square feet are inside of 1 square yard? You actually have 1, 2, 3, 4, 5, 6, 7, 8, 9. You have 9 square feet inside of 1 square yard. So let me just write that down over here. 9 square feet equal 1 square yard. So if I have this many square feet and I want to figure out how many square yards it is, for every 9 square feet I have, that adds up to 1 yard. So I want to take this value and divide it by 9. And after you do that, we get 1660.37 square yards. So 1,660.37 square yards. And now I can finally get to the ultimate question of here, the cost. Now that I know the square yardage, it's 1660.37, and each one of those square yards costs 3 cents. So multiply 1660.37 times 0.03, and we get $49.81. And that's our answer to the cost to cut this yard. Okay, our first goal is to determine the number of cubic feet of water that this water trough would hold. And this is a prism, basically, is the shape here, and we're trying to find the volume of this prism. We know several things. The width of the top of the trough is 6 feet. The width of the bottom of the trough is only 2 feet. We know the trough is 12 feet long, and we know that the diagonal length of the side is 4 feet. And so ultimately I'm trying to find the volume here. Well, for any prism, we can multiply the area of the base, which in this case is a trapezoid, times the height. So if we were to stand this trough up on end where we made this the base, we have a height of 12 feet and a base that is a trapezoid. So I need to figure out the area of that trapezoid in order to calculate the volume of the trapezoidal prism. So I'm going to start there. The area of a trapezoid is 1/2 times the height of the trapezoid times the sum of the two bases of the trapezoid. So we've got to see which of these figures we have. Well, the two bases we do have, because if we're just dealing with the trapezoid, one base is 2 feet long and the other base is 6 feet long. But what about the height? Well, it's not 4 feet. So if I could recreate the end, just the base portion of the trapezoid, it looks like this. I know this is 2 and this is 6, and I know this diagonal length is 4. The height of the trapezoid is measured by the perpendicular distance. So if we were to draw a vertical line right there, that would be the actual height of the trapezoid, so that it meets at a right angle on both ends. So basically, I need to figure out h here. Well, if you look at this closely, you see that we have a right triangle where the hypotenuse is of length 4, and one leg we can actually calculate. If we draw the height right here, if you were to draw a similar height over here, you see that would split this region into 3 equal portions, and if the whole thing is 6, then this little piece must be 2. So I have a right triangle with one leg being of length 2 and a hypotenuse of length 4. I can therefore calculate the height. So I can just pull that figure out. This is what we have. So the Pythagorean Theorem gives us a relationship between the lengths of the sides of a right triangle. I know that the sum of the two squares, the sum of the two squared legs has to equal the square of the hypotenuse. So I can take a time out for my area calculation to figure the height here is 2 squared plus h squared is equal to 4 squared. Let me write it that way. I know that the sum of the two squared legs has to equal the square of the hypotenuse. So 2 squared plus h squared equals 4 squared. So 4 plus h squared equals 16. Subtract 4 from both sides to get h squared equals 12. And so h is the square root of 12. And if you remember back to maybe a former algebra class, the square root of 12 can be written as the square root of 4 times 3, because 12 is 4 times 3. And so you can write this as the square root of 4 times the square root of 3, and the square root of 4 is 2. So you can simplify square root of 12 down to 2 square root 3. So that would be the height of our trapezoidal base. So back to the area calculation, if I want the area of my trapezoid, it's 1/2 times the height I just calculated, 2 square root 3, times the sum of the two bases, which we said were 2 and 6. So 1/2 times 2 is still 1, so I just have the square root of 3, and 2 plus 6 is 8. So I have 8 times the square root of 3 being the area of the trapezoidal base. Now, volume of a prism is given by area of base times the height of the prism. We just calculated the area of the base because the trapezoid is our base. We know it's square root of 3 times 8, or 8 times square root of 3. Now this height is different from the height we calculated earlier. This height is referring to the height of the prism. So if we were to take this water trough and stand it on end, it has a height of 12 feet. So I have 8 times square root of 3 times 12, or 8 times 12 is 96. So 96 square root 3 cubic feet. So that's the exact value, and if at this point you want to change it to a decimal to see what that is, that's okay. So this is approximately 166.28 cubic feet. And either the exact or the approximate value at that point is what our final answer is. And that's the answer to part A of this problem. Now part B asks us to determine the total weight of the trough. So the weight of the trough, well, we know that the empty trough weighs 400 pounds, so the full trough is going to be 400 plus however much the water weighs. We're told that water weighs 62.4 pounds per cubic feet. We know that we have 96 square root 3 cubic feet, so I need to multiply that by 62.4. Again, notice I'm using the exact value, trying not to use any rounded values till the final. So your calculator can handle all of this at once in the calculator. 400 plus 96 square root 3 times 62.4. Type all that in at once. And I get 10,775.68 pounds if we round it to 2 decimal places. That's the answer to part B. Now, part C asks us for how many gallons will the trough hold. I'll use G for gallons. And we know that each gallon of water weighs 8.3 pounds. So the tempting thing to do here at this point is just divide this by 8.3. But you have to be careful, because this is not just the weight of the water. This is also including the weight of the trough. So before I divide it by 8.3 pounds, I want to get rid of the 400. So I just want this portion, the 96 square root 3 times 62.4. That gives me a certain number of pounds, and that's just the poundage of the water. I want to take that value and divide it by 8.3, because for every 8.3 3 pounds, I get 1 gallon. So typing all that into the calculator and rounding to 2 decimal places, get 1,250.08 gallons of water that this water trough would hold. And that's our answer to part C.